You've probably heard the word blockchain a million times, right? Usually it's all tangled up with crypto headlines. But today, we're going to slice through all that noise. We're going to look at the incredible technology behind the hype. So let's get right into it.
Okay, let's kick things off with a problem I'm pretty sure we've all run into: sending money. I mean, look at this. On the left, you've got your standard bank transfer. Takes days, they hit you with big fees, and you're totally relying on them as a middleman. Now look at the right. That's the blockchain way. We're talking minutes, fees are just pennies, and guess what? No middleman needed. This huge difference is exactly what we're going to unpack today.
And really that core difference? It all comes down to one single thing: the trust problem. Yeah, at its heart, this is all about trust. Think about it for a second. So much of our digital lives, whether it's banking or even just scrolling through social media, forces us to trust some big company in the middle to handle everything fairly. Well, blockchain was built from the ground up to solve that exact problem, to get rid of the need for that trusted intermediary.
This question right here really gets to the core of it all. What if we could create a system where no single person controls it, everyone can verify everything, and records can never be changed? I mean, that sounds pretty impossible, doesn't it? A system with no boss, where nothing can be secretly altered. But back in 2008, the mysterious Satoshi Nakamoto actually came up with the answer. And it wasn't Bitcoin the currency. It was the underlying technology that makes it all work: blockchain.
All right, so what is a blockchain, really? The best way to picture it is as a special kind of shared digital record book. You know, like a ledger. But this record book has some really unique superpowers that make it totally different from anything we've ever had before. Okay, so the official technical definition is a distributed, decentralized public ledger. Sounds a bit like a mouthful, right? Let's break that down real quick. Public is easy. It just means anyone can take a look at the records. Decentralized means there's no single company, no single person in charge. And distributed, well, that's where the magic really happens. And this is the key to its security. Think about a traditional bank. They've got one big central ledger on their servers. If that gets hacked, well, that's a huge problem. It's a single point of failure. But in a distributed system, you have thousands of identical copies of that same ledger spread all over the world. So if a hacker wanted to cheat the system, they'd have to successfully change over half of those copies, all at the exact same time. It's practically impossible. It's basically security through massive duplication.
So, where does the block in blockchain come from? It's pretty simple, actually. Transactions, like sending money, are bundled together into a block. You can think of a block as just one page in our digital record book. And once that page is full of transactions, it gets sealed with a unique, tamper-proof digital fingerprint called a hash.
And this is where the chain comes into play. It's so clever. Every new block doesn't just get its own unique hash. It also contains the hash of the block that came right before it. So, as you can see, block number 2 is literally pointing back to block number 1. This creates a secure, cryptographic link, a chain of blocks. Now, this is what makes the whole system so incredibly secure. It's what we call immutable, meaning it can't be changed. Let's say some bad actor tries to go back and alter a transaction in an old block, like block number 1 here. The second they change even a single piece of data, the hash for that block completely changes. But wait, block number 2 is still pointing to the original hash. That link is now broken. And it's not just that one link. The entire chain from that point forward becomes invalid. The fraud is immediately obvious to everyone on the network. It's genius, really. Okay, that's the basic structure. We've got blocks, we've got a chain. Now let's follow the journey of a single transaction to see how it actually gets added to the super secure shared record book.
So how does it all happen? It all starts with, let's say, Alice. She uses her digital wallet, which is basically just a secure app, to create and digitally sign a transaction. Step 2, that transaction gets broadcast out to this huge global network of computers, which we call nodes. Then, all of these nodes check the transaction. Does Alice actually have the funds? Is her signature legit? Once it's validated, special nodes, we call them miners or validators, get to work. They bundle a bunch of these valid transactions into a new block. Finally, that new block gets successfully added to the end of the chain, and voila! Alice's transaction is now confirmed, and it's a permanent part of the record. Now, that really important step, how the network agrees on which block to add next, that's handled by what's called a consensus mechanism. It's how thousands of different computers can all agree on one version of the truth without having a boss tell them what to do. The original method, used by Bitcoin, is proof of work. It's like a massive, energy-guzzling race to solve a complex math puzzle. A much newer method is proof of stake, which is more like a lottery. Participants lock up some of their own coins as collateral for a chance to be chosen to create the next block.
And the difference between these two is massive, especially when it comes to energy. Just look at this chart. That switch from proof of work to proof of stake, something the Ethereum network famously did, can slash energy use by an incredible 99.95%. I mean, that is a game changer for making this technology sustainable. All right, we've got the tech foundation down. Now for what I think is the most exciting part. Let's look at how this isn't just about digital money anymore. We're going to explore how blockchain is being used in the real world in ways that might really surprise you. First up, let's talk about supply chains. Just try to imagine tracking a head of lettuce from a farm across the country to your local grocery store. Or think about a diamond, from the mine to the ring on someone's finger. It's an insanely complex journey, right? Full of paperwork, potential for fraud, and lots of blind spots. Well, blockchain provides a pretty elegant solution. It creates a single, shared, unchangeable record of a product's entire life story. Take Walmart, for example. They're using it for food safety. If there's an E. coli outbreak, they can pinpoint the source in minutes, not weeks. It's a huge deal. Or De Beers, the diamond company. They use blockchain to prove their diamonds are conflict-free. It's all about bringing trust and transparency where it was missing before. Okay, next up, healthcare. Right now, our medical records are a mess. They're fragmented, stuck in different computer systems at different doctors' offices and hospitals. You don't really own them. But what if you did? What if you were in complete control of your own health data? This is where blockchain comes in. You could hold the single digital key to your entire medical history. When you see a new doctor, you could grant them temporary access. It makes everything interoperable and secure. The country of Estonia is already doing this with their national health records. It's also being used to fight the massive problem of counterfeit medicines by tracking drugs from the factory all the way to the pharmacy. Okay, this next idea is one of the most powerful things to come out of blockchain, the smart contract. Forget lawyers and paperwork for a second. A smart contract is just an agreement written in code that lives on the blockchain. It's basically a computer program that runs on a simple if-then logic. For example, you could have a flight insurance policy that says, if my flight is officially delayed by more than 2 hours, then automatically send the payout to my wallet. No claims forms, no phone calls, no waiting for approval. The trust is baked right into the code. But, and this is a big but, blockchain isn't some magic wand that can fix everything. It's really important to be realistic and talk about the challenges. The technology still has some pretty big hurdles to clear before it goes mainstream. So what are the biggest roadblocks? Well, first, there's scalability. Most blockchains today are pretty slow compared to something like the Visa network. We also already talked about the energy consumption of the older proof-of-work systems. It's a huge environmental concern. Then there's regulation. Governments are still trying to figure out how to even approach this new borderless tech. And honestly, for most people, using it directly is just way too complicated. The user experience has to get a lot simpler. So, after all that, the good, the bad, the complicated, where do we go from here? What's the big idea we should walk away with? It really comes down to this question, doesn't it? Is blockchain the future? Is it going to change everything we do, or is it just a lot of hype? And here's what I think is the most important takeaway. The real, lasting revolution of blockchain might not be about any single cryptocurrency or app. It's about what it proved to the world. It proved that it's possible for huge groups of people who don't know or even trust each other, to come together, coordinate, and agree on a shared set of facts, all without needing a bank or a government or a big tech company in the middle. That idea that decentralized, trustless agreement is possible at a massive scale, that is a profoundly powerful concept. And that is the true innovation that's worth watching.